Bismillahirrahmanirrahim. For today, we are going to discuss the implicit differentiation. What we have discussed before was called the explicit differentiation. We have two types of function. We have implicit equation or function and explicit equation. For the implicit or for the explicit, the first type we call it explicit function. Explicit function, it is the function that's written as y equal to f of x, where we are keeping the y in one side and all the x variables or x variable in the other side. These can be separated y equal a function of f of x. For example, y equal to x square minus 4x plus 5. We call this as explicit function. Y is written explicitly as a variable of x or as a function of x only. So y on the left hand side equal some function on the right hand side. Explicitly there is no y. And in this form it is very easy to find the derivative. If we differentiate this function, the derivative y prime is equal to 2x minus 4. It's very easy to find. But in some cases, the variable y is not written explicitly as a function of fx. We can separate y from x. That's what's called the implicit function. Implicit function. And implicit function where y, or it cannot be written as y equal to f of x, or in some cases it cannot be. Or if it is written as the x variable with the y variable in one side plus some also termed in the other side. For example, y x minus 2x over y plus 1 equal to 3x. Since we have x and y in the same side or some terms contain x and y, we call this is implicit equation, or y is defined as a function of x but not explicitly. It is a function of x implicitly. In these cases, we need to find the derivative but without writing y as explicit function of f of x. So this equation now is implicit equation, or y is written as a function of x implicitly. Now let's use this one implicit differentiation to find the derivative of some functions. Find y prime by using implicit differentiation. Number one, we have x to the power 3, y to the power 2 minus 5x, y plus x equal to 1. And I need to find the derivative of this function. So I will differentiate this one. So to differentiate it is d with dx over dx. It means we are differentiating the equation with respect to x. differentiate the left hand side and the right hand side with respect to x. Now for the first term, I have x to the power 3, y to the power 2. This term, it is a product. It is multiplication of two variables x and y, or I can say it is like a multiplication of two functions. I have x to the power 3 and y to the power 2. To find the derivative of this one, I'm going to use the product rule. By the product rule, it is f prime g plus g prime f. So I'm going to differentiate the first one, x to the power 3, the derivative is equal to 3x squared multiplied by y squared. This is the first function. F prime to the 3x squared multiplied by y squared. Now the second term is g prime to the derivative of the second function. That will be plus. Now we are differentiating the second one, which is y squared. I will have 2y multiplied by x to the power 3. But we have to be careful about one thing. Each time we have or we differentiate a variable y, we must have y prime. Each time we differentiate y, we must have y prime because we are differentiating with respect to x. This y squared, it is like y bracket to power 2. By the chain rule, this is 2 multiplied by y, then the derivative of what is inside is y prime. So we differentiate the power, then we differentiate what is inside that one. So it is 2y multiplied by y prime. Be careful about this one. Now this again. So it is 2y multiplied by y prime. We must have this each time. X to the power 3. Again, this is the derivative of y squared. So the derivative of y squared is equal to 2y multiplied by y prime multiplied by x to the power 3. Now let's go for the second term. Second term, we have minus 5. Open the bracket. Because I need to also apply the product rule for this one. Again, it is f prime, the derivative of x is equal to 1. So it is 1 multiplied by y plus. Now the derivative of y is y prime multiplied by x. Again, this is the product rule. Derivative of the first function multiplied by the second plus the derivative of the second one multiplied by the first function. Now, the derivative of x is equal to 1. Equal derivative of 1, the right hand side is equal to 0. So we are now done from the differentiation. All what I need, just code algebra to write y prime equal to something on the right hand side. But let me rearrange it first. I have 3x squared y squared plus 2y prime x to the power 3. Open the bracket, will be minus 5y minus 5y prime x plus 1 equal to 0. Which can be written as, I will keep the term with y prime on the left hand side. I have two terms, and the others move them to the right hand side. So I will have 2y prime x to the power 3 minus 5y prime x equal to, move it to the other side, will be minus 3x squared y squared plus 5y minus 1. We moved these terms to the right hand side. changing the sign will be minus 3 plus 5y minus 1. Now in the left hand side we have y prime as a common factor. I will take it as a common factor. So it will be 2y x to power 3 minus 5x equal to minus 3x square y square plus 5y minus 1, or y prime will be minus 3x square y square plus 5y minus 1 divided by 2y x to power 3 minus 5x, and that is the derivative. So we used implicit differentiation to find y prime. We didn't try to write the variable y as a function of x explicitly. Just differentiate what we have the left hand side, right hand side, then solve for y prime. Let's take another example. Number 2. Y to power 3 plus yx square plus x square minus 3 y square equal to 0. And we need to find y prime. So we will differentiate the left hand side and right hand side with respect to x. dy dx of y to power 3 plus yx square plus x square minus 3 y square equal to the derivative of the right hand side with respect to x. Now the derivative of the first term, y to power 3, this one, it will be 3 y square multiplied by y prime, as I mentioned before. Each time we differentiate y, we must have y prime. So y to power 3, we differentiate the power, it will be 3 y to power 2 multiplied by y prime. Be careful about this point. We must have y prime. Now the second term, it is product rule. This is product rule, which is f prime g plus g prime f. F prime means y prime multiplied by x square plus g prime, it is the derivative of the second one, which is 2x multiplied by y. This is product rule of the second term. Now third term, I have x square, so it is plus 2x. Third one will be minus 3 multiplied by 2. We differentiate the power. It is 3 multiplied by 2 multiplied by y, and we must have y prime equal to 0. We must have y prime each time we differentiate y. Now I will keep the terms that with y prime on the left hand side. These are this term and this term and this. We have 3 terms. So I have 3 y prime plus y prime x square minus 6 y prime equal to minus 2x y minus 2x. Just move this term to the right hand side. Now in the left hand side I will take y prime as a common factor. I will have 3y plus x square minus 6y equal to minus 2xy minus 2x. So y prime will be minus 2xy minus 2x divided by the coefficient of y prime, which is 3y plus x square minus 6y. So this is the derivative of the function, but we use the implicit differentiation. Again, we use implicit differentiation. Take one more. Number 3. X square equal to x plus y divided by x minus y. And we need to find the y prime for this function. I can apply the quotient rule for the right hand side, but that will be complicated a little bit. But so first let's simplify the form of the equation. If we do cross multiplication, I will have x square multiplied by x minus y equal to x plus y. Open the brackets, x to power 3 minus x square y equal to x plus y. This now will be easier than applying the quotient rule. I just simplify the form of the function or the equation. Then I'm going to differentiate this equation. So d by dx, let's now differentiate. Equal the derivative of the right hand side. Now the derivative of x to the power 3 is 3x squared minus, open the bracket. Because for the product rule it is f prime g plus g prime f, but since I have a negative sign, I will leave it outside, then open the bracket to avoid any mistake in the sign of the second term of the product rule. So this is the product rule. So the derivative will be 2x y plus. Derivative of the second one, it is y prime x squared. Derivative of y is y prime x squared equal, derivative of x is 1, derivative of y is equal to y prime. Now open the brackets, rearrange the terms to find y prime. I have 3x squared minus 2xy minus y prime x squared equal to 1 plus y prime. This one, I will move it to the left hand side. And the terms without y prime, I will move them to the right hand side. So in that case, I have minus y prime x squared minus y prime equal to, if I move this one, I will have minus 3x squared. This one will give me plus 2xy plus 1. Now for the left hand side, take y prime as a common factor. It will be minus x squared minus 1 equal to minus 3x squared plus 2xy plus 1. Then y prime will be minus 3x squared plus 2xy plus 1 divided by minus x squared minus 1. And this will be the derivative, or this is y prime. It's given as a function of two variables. It is not only x on the left hand side, it is x and y. So y prime equal minus 3x squared plus 2xy plus 1 divided by minus x squared minus 1.